All right. 10 minutes has elapsed. Still waiting on one person, but this isn't graded, so it's okay. We'll start reviewing it. But whoever's still working on it, just submit it once you're done. All right. What'd you think? Do you think you could get an apple to orbit a rather overweight, obese person like Peter Griffin? Be,
Yes.
be an interesting world if you could. But yes, let's delve into what's going on with some of that. So Google, I like, also does an instant analysis. So it looks like you are all feeling good that yes, he is saying that Peter's so fat that he exerts a strong enough gravitational pull to actually bring things into orbit around him if he's close enough to them. Theoretically, though, why does Brian throw it? So a lot of you got at this. What does the apple technically need in order to actually get into orbit around Peter? What's kind of the vocab word? Some of you got it. It's from like the very first part of chapter 5, back when we were talking about Newton and his apple.
It needs to move faster than like the fall.
Yep. That's who remembers the term? What was the term for that? The parallel movement to Earth's surface, or in this case, Peter's body.
Tangential velocity?
Yep. Yeah, tangential velocity. So, and I don't think it's coincidence that they use an apple as the first object that he throws at him, right? I think that's sort of a bit of a reference to Newton and gravitational stuff. So there is a bit of a flawed argument, though, because he says you're so fat you exert your own gravitational pull. What does Brian not realize? How's that flawed?
Everybody already exerts their own
Yes,
gravitational
and
pull.
most of you got that we all have gravitational pull. It's just so insignificant that it doesn't make a difference. We don't notice it at all. If you do the math, it doesn't matter. Like, I know I put numbers in there. I tried to come up with realistic numbers, but it doesn't matter because you're going to get an answer that's super, super small because of, and half of you got this right. So the gravitational constant, G, is a very, very small number. Remember, it's times 10 to the negative 11. So that's 0.0000000. That's what guarantees that it shows the gravity is a very weak, weak force, and you need an incredibly large mass, way bigger than what any overweight human could achieve, to actually have a significant amount of gravitational impact on something. In terms of who Rube Goldberg was, and even I didn't realize this, honestly, and so I started to look it up. He was a cartoonist. He was like a political cartoonist in the 1910s, 1920s. But one of the other things he did was he drew these comics of these insanely fancy machines, and that is now what people are basing this off of. And they even referenced the OK Go video that we watched. And it's interesting to see that, I mean, almost 90% of you didn't realize who Rube Goldberg was. And I was the same thing. I thought he was like a physicist who did these machine building on the side, or was maybe an educator or something. But turns out he wasn't related to it at all. So kind of cool, interesting stuff. Okay, the next task, again, I hate to sort of repeat this, but we're basically going to do a bigger version of what we just did. We're going to have you watch 2 videos. These are a little more serious about gravitational force and orbit. And just to change it up, because I know I've been giving you guys a lot of like Edpuzzle and a lot of Canvas quizzes and everything else. So this time it's just going to be a Canvas discussion. So there's a link to it right there, U4L17 satellites in orbit and gravity visualized. Here's what it'll look like. And so there's 5 questions I'd like you to answer in your discussion post. You're just going to hit reply down on the bottom, and you can number your answers. You could use bullet points, or you can just type in one big paragraph. It doesn't matter to me. I'll figure out, whether or not you answered each question. But watch the first video, which is how do satellites get and stay in orbit. It's a sci show. I think it's about 4 minutes long. And answer those 3 questions based on that. And then there's one more video. I only want you to, this video I think is 10 minutes long. I only want you to watch the first 5 minutes. So only watch the first 5 minutes, then you can stop, and you can answer those 2 questions down there. And then we'll come back together to discuss it. So I'm going to give you about 20 minutes to work on this. And as usual, I'll be here listening in case something doesn't work or if you have a question, but otherwise 20 minutes to work on that Canvas discussion post and watch those 2 videos. Go for it, and we'll check back in after that. All right, kiddos, 20 minutes has elapsed. Let's come back together. Looks like about half of you have been able to submit a post to the discussion. If you're not finished, this can just roll over into homework. I want to give you time to work on the next little activity. What you can do, I'll share my screen here really quickly, is you can just post your response, even if it isn't done. Like even if you've only answered the first 3 or first 4 questions, just hit post. And when you come back to the discussion later, in the upper right corner, you'll see these 3 dots. I know it's sort of hard to see, but if you look there, there's 3 little dots in the upper right corner. It's sort of subtle. But if you click on those, one of the options you will get is edit. And so you can just post your post here. That'll sort of save it. And then you can come back here and then edit and continue to work on your answers later on. So I would just go ahead and hit post so that it's all there, it's all saved. You're not going to lose it if you accidentally close the window or something, and then you can come back and work on it later. Feeling good on this? Thought the videos were kind of interesting. How'd you guys feel about that whole idea of a disposal orbit versus deorbiting satellites? What did you think? Do you think we should deorbit them or put them in disposal orbit?
I like disposal orbit because then like it's out there, and then if like aliens find it, they're like, "Oh, sick!" And
Yeah.
sharing satellites with them.
Yeah. Some people argue it's actually sort of the opposite, that the reason intelligent life hasn't reached out to us is because they've seen our planet with all the trash floating around it, and they're like, oh, we've got to stay away from that species. But I don't know, that's a joke I've heard before. But I guess what I was kind of getting at with that question is, would you consider that a form of pollution? The fact that we're dumping satellites into our outermost orbit? What do you think?
I don't think it counts as pollution because like it's space, and like yeah, we haven't even like explored like all this like space yet. We only know our Earth and the Moon so far,
Mm-hmm.
or that's like the speculation. I don't have proof that someone's been to the Moon. They got the videos, but like I'm someone who believes that we've been to the Moon, but like I need to see proof. But like
Well,
I say, if we're just throwing satellites out there, I don't think it matters because there's so much empty space. Like probably aliens are doing it too somewhere.
yeah, yeah, it's true. It's sort of interesting to think that no matter what happens in human society, like if things fall apart, there's still going to be satellites falling out of the sky that will land on Earth. That I'm sure whatever caveman or species is left over will be like, what is this?
Yeah.
But kind of interesting. And the second video was all about. Gosh, I'm even forgetting what we did for that second video. I'm still stuck on the do now. Oh, it was all about the fabric space-time. So yes, that's what I want to give you time to do. So activity that we're going to do for the last 20 minutes of class. I want to have 10 minutes to work on this, but we are going to try that activity that you saw in that second video. Now, I know you can't reproduce this perfectly at home, but I kind of test fired a couple little at-home versions, and they're not perfect, but I think it's something that you can all try. So task number 3, the activity is gravity visualized. It is another Flipgrid. I'm sorry if you're getting sick of all the Flipgrid stuff, but here's what it looks like. I've got a little instructional video. It's about 6 minutes long that I encourage you to watch, so it'll give you an idea, and then run out and find your materials. You're going to need a pot or a pan or something like that, a fabric of some kind, or if you have cellophane wrap, use cellophane, something to attach it, something round that you can throw or roll around and get into orbit. But anyway, I explained it all in the video. The instructions are also both on the Flipgrid assignment. They are also right here on the activity list, the description. I tried to break it down into 3 basic steps. And then the video, there are 3 things I want you to do in your video. One is just show that the satellite falls to the center when you let go of it. That's your gravity bending space-time. And then that you can get at least 1 circular orbit. That's what I want to see, is just 1 time around at least, and give a little description of what's going on. So again, watch the instructional video, see what you can do in the next 20 minutes. And again, we'll touch back together just to go over the homework assignments and things in 20 minutes. Once again, I am here if you need help or advice, or you're not sure what materials to use. Go for it. All right, kiddos. In 20 minutes, let's come back together. Hopefully we're all still by our computers. Looks like about 5 of you were able to post videos, which is great. It's about half, and the ones I saw were pretty good. Looks like it was actually working out. Barry, I liked your use of a trash bag. I didn't think about that. Everyone has trash bags at home, so you don't have cellophane. That seemed to work pretty well. You guys have fun bending space time?
Yeah, it was so hard to get the rubber band around the bowl though. It like broke every time. I connected like three together and it was so annoying.
Yeah. Yeah, last night I was trying every different way, and yeah, I had some more creative ones that didn't quite work out, like rubber bands and stuff. I don't have the right size, but yeah, but it looks like most of you got it to work. If you didn't get something posted, again, that will just roll over into homework. But again, try not to spend too much time on it. Like if you're really having a hard time, if you don't have the materials at home, just let me know. It's okay. I understand, and I can just excuse you from the actual assignment. But it was just meant to be sort of a fun demonstration of how Einstein was thinking about gravity. He didn't necessarily think of it as a force, but more of an adjustment in this idea of what he called space-time, right? It's his theory of relativity. And so we'll be using some more simulations in our next lesson, specifically PhET simulations, to play around with this a little more and look at what's actually happening with the forces. So, okay, to conclude, homework is some Hewitt reading. So obviously you should finish up anything you didn't get done here in class. So the discussion post questions, make sure you've answered those 5 questions, and just submit a video to Flipgrid with a little bit of a description of what you're doing as well. But I would like you to read Hewitt chapter 28.1 and 28.2, which is going to be all about our solar system and just introducing you to how it was formed. And there's no reading quiz, but I would like you to do read and check questions. So just like we did in chapter 5, this time they're on page 859. They're at the end of chapter 8. I'd like you to do the odds 1 through 9. So 1, 3, 5, 7, and 9. Should be pretty straightforward. This is just the beginning of the chapter. But that's all you have to do for Friday. Any questions on that? I've been reading through your feedback on the midterm comments, which is great. Thank you very much for the feedback to me. There's definitely things I'm trying to take note of, and including more games and things like that is, I think, good to keep the lessons engaging. On that note, I would like, if I could have Edward and Will just hang out here in the room. I just want to make sure that you're on track for completing those reflections, but otherwise everyone else, you're good. Thank you very much. Have a good day.